So the Claisen reaction is a nice way to make kind of multiple carbonyl compounds, right? And so we can make 1,3-dicarbonyls and all this other stuff. We use enolates, we use esters. This kind of stuff works really well. So I just want to compare the Claisen reaction to the Aldol reaction that we saw in previous um, videos. And so we can kind of see what's different about one or the other. Claisen versus Aldol. Okay. So the Claisen reaction is, I guess we'll start with Claisen. The Claisen reaction is enolate plus ester. And so whatever your enolate is, let's say we'll use an ester enolate this time. I'll use an ethyl ester. We'll make this a benzene ring this time. Plus an ester over here. This will be, oops, drew it too close. Whatever. We'll just make this a nice propyl group. So in this case, we have two esters. We would just take this first one and treat it with a base first, sodium ethoxide. Notice that I'm using an ethoxide, the two carbons ethyl group with an oxygen here to replace this. Notice that the reason I do that is in case we do carbonyl substitution here, right? If this adds to the carbonyl, instead of removing the hydrogen, if this adds to the carbonyl and we lose the leaving group, we actually just make more of our starting material. So you always kind of want to match your base to your ester. Here, we'll talk more about that here in a minute. Okay, so we make the enolate by adding a base, and then we add to the ester. Right? And so we're going to remake the carbonyl. The alpha position is nucleophilic. It adds to the carbonyl over here. Benzene ring is attached to the alpha carbon. That. And the alpha carbon is attached to the carbonyl carbon. You get this. And then, of course, all that's left is kick out the leaving group and make the 1,3-dicarbonyl. Right, so our final product in this case will be and notice the way I'm drawing this. I'm drawing in the 1,3-dicarbonyl first. This is our alpha carbon right here. This is where we made the enolate. We had a benzene ring attached there. And so our final product would be this. And notice again, we can do the carbon counting part. Right? If we ignore the whatever group is attached to our oxygen, we have 8 carbons over here. We have 2 carbonyl carbon, alpha carbon, and 6 carbons on the benzene ring. Over here we have carbonyl carbon and then 3 carbons of the isopropyl. So we have 8 carbons and 4 carbons. If we add all these up, we have 12 carbons plus whatever ester group we have here. But notice that we always get a 1,3-dicarbonyl in this case. Okay. Now an aldol reaction, right, we can do an aldol reaction with, we'll use a similar set of if we use a similar set of things, I'm going to make the enolate here. I'm going to use LDA. It's a nice strong base. Remove that hydrogen. Make the double bond. Make our enolate. Okay, notice that the first step is the same, right? Aldol is enolate plus aldehyde or ketone. Remember that whenever we say aldehyde, we could also mean ketone. Once we make the enolate, right, now we react with the aldehyde. And we get, once again, reaction taking place at that alpha position. Only this time we're not going to remake the carbonyl, right? We don't have a leaving group attached to our carbonyl carbon in this case. So that hydrogen that was there is still there, but the hydrogen is not a leaving group, and so the hydrogen is not going anywhere. And so in this case, instead of getting remaking a carbonyl at that 3 position, we're just going to end up with an alcohol. Right? So when we work this up, we would add an H plus there, and we get something that looks like this. So again, I'm taking kind of a similar 8-carbon enolate, a 4-carbon electrophile, only I'm using an aldehyde instead of an ester this time. And the difference in the product that we get is, in this case, we get a 1,3-dicarbonyl, carbonyl and carbonyl. In the Aldol reaction, we get a beta hydroxy carbonyl, right? So we don't remake the carbonyl, instead we're just left with an alcohol. So those two reactions are similar, but obviously different, right? They both go through the enolate. We have to work on making enolates and having those enolates attack carbonyls. The difference between them is identifying when do we have that leaving group so that we can lose the leaving group and remake the carbonyl, right? That's the big difference between the Claisen and the Aldol. In the Aldol reaction, there's no leaving group there. So you add to the carbonyl and you just end up with an alcohol. In the Claisen reaction, you add to the carbonyl and there's the leaving group there, so you can reform the carbonyl, kick out the leaving group, and you make your dicarbonyl compound.